or length of opening. Now, the longer the aperture, it means the wider the opening of the curvature of the reflecting surface, the longer is the focal length as well. Okay, because focal length and center of curvature or radius of curvature depends on how wide or narrow the length of aperture is. So the narrow or the narrower the aperture, it means the shorter will be the focal length. The closer will be the focus and now let's have some examples of ray diagram when we do the ray diagram if you want to discover the rest, okay, in the activity. So when we do the diagram for concave, so let's have an example for that. Wait first. Wait. I lost my. Here. Okay, so here is an example. So let's have the ray diagram for concave mirrors. So like what I told you, there are 6 cases for concave mirrors, but let me just introduce one of those cases. And at this case, the object is outside C. Okay, so when we say outside C, uh, it means if this is point C, the object is here. So it's further away from point C. Okay, with respect to the vertex, so it's further away. So it's outside. Okay, so how do we present the ray diagram when the object is outside point C? How do we describe the form? So in order to identify the image form, so let's do the ray diagram. So when we do ray diagramming, you do 2 sets of incident and reflected rays. Okay, so let's proceed first with the of incident ray and reflected ray. So for the incident ray is coming from head of the object and striking the mirror, the reflecting surface. And make sure that this line is parallel to the principal axis. Okay, and then that's the incident ray of the first set. And then for the reflected ray, it will bounce and this is the second set. I mean, this is the reflected ray of the first set. Okay. Now for the second set, so it's still starting from the head of the object, and then it will be striking the focus. Okay, so passing the focus, striking the reflecting surface. So that's the second incident ray, and then for the reflected ray, it will bounce and become parallel to the principal axis. Also make sure it's parallel. Okay. So again, first set of light rays, so incident ray and reflected ray. Second set of light rays, so this is the incident ray and reflected ray. Now, once you have presented the 2 sets of light rays with the 2 reflected rays, search for the possible point of intersection. Do you see any point of intersection of the 2 reflected rays? for for any point of intersection of the two reflected rays. If you can annotate, try to mark the point of intersection. Okay, who's the thing? Jaya? Okay, and who's the other one? Huh. Okay, so yes, that's the point of intersection. So let's put point for this one. Once you have identified the point of intersection, you are going to draw the image form. Now, at the point of intersection, you draw the head of the image, and then the body of the image will be towards check. This is the image. Now, out of this diagram, we are going to draw a conclusion that will describe the image form by this given situation, or in this given situation. So, uh, when you present the conclusion, a conclusion for the uh, description of the image form, so you will be presenting them this way. So you start with the type of image, so whether it is real or virtual. So that's the first. Second, you will present the size of the image. So how do you present the size of the image? It's either or same size. Okay, so that's the second. And then the third is the position of the image. So how is the image? Uh, is it erect or upright, or is it inverted? Okay, so that's how you're going to present or draw a conclusion out to describe the image. So let's start with type of image. What type of image is formed?
Real image.
It's a real image. Yes, Jaya. Why is this a real image?
Because the image is formed in front of the mirror.
Okay, exactly. Yes. So since it is formed in front of the mirror, it is real. And if you are going to put a white screen there, somewhere in front of the mirror, you can able to see or project at the white screen a sharp image of the object. Okay, so that is possible because it is real. Okay, it's a real image. Next, size. What uh, what can you say about the position of the image?
Inverted.
Inverted, yes, Jaya. So it is okay, and this is how we describe the image. Uh, the description of the image. Okay. All right. So this is only one of the cases for concave mirror. What are the other cases? The other cases is when the object is found here at point C. Another, if the object is found between C and F. So what would happen to the image? And then if the object is here at the focus, the other one is if the object is between F and V. And finally, when the object is touching the mirror. So those are the other five cases. And you are to discover how the image would be. Okay, if you place the object at those locations. Okay. So that's for concave mirror. Now this time, let's do convex.